In this video, we're going to be looking at permutations and combinations. Permutations and combinations are both methods of counting the number of ways in which we can select a smaller group of objects from a larger group. So our first example is going to be looking at an Olympic swimming race. So this is the 4x200 from 2012. So we've got 8 countries, and there are 3 of them that are going to medal. And so we can see the race results here on the left-hand side. But before the race, a question that might be asked is how many different ways could 3 teams medal out of the 8 teams in this race? So let's take a look. So the way we're going to do this one is by drawing 3 lines, one for each medal. So gold, silver, and bronze. We want to know the number of different ways in which these teams could come in. So the first one, before the United States finishes, when this race first starts, there are 8 different teams that could have come in first place, any one of the 8 teams. Now after the US comes in first, they're crossed off, that we can't come in any other place. So then there are 7 teams left that could come in second place and win the bronze. So once France finishes, they're off the list. And then after that, there are then 6 teams left who could get bronze. Then once China's finished, then we've got our 3 teams selected. So the way we compute this, the total number of ways in which 3 teams could have come in the first 3 places out of 8 teams is just 8 times 7 times 6. And that equals 336 different ways. So there were 336 different ways that the medal stand could have looked after this race. Now, what if there were 50 teams and we wanted to look at the top 25 finishers? Well, so what we would do is we would do 50 times 49 times 48 times 47 all the way down, and that would take forever. So we don't want to do that. That would take forever. So we want to come up with an easier way than that. So we want to come up with a formula for figuring this out. This works nice and easy if we just have 8 teams and 3 teams coming in, or 3 teams medaling. But if we have more, it would be a little bit more difficult. So what we're going to use is something called factorials. And a factorial in math is exclamation marks. So this is a factorial. And what it means is, let's look at just 4 factorial, for example. So 4 factorial equals 4 times 3 times 2 times 1. So a factorial is whatever this number is times all the numbers below it. So we're going to use that to figure out a formula. Now we had 8 times 7 times 6. We knew that was 336 for this particular race. Now if we started off with 8 factorial, that's 8 times 7 times 6, which is what we wanted, and then 5 times 4 times 3 times 2 times 1, which we didn't want. So what we can do to get rid of the 5 times 4 times 3 times 2 times 1 is just divide by that. 5 times 4 times 3 times 2 times 1, which would be 5 factorial. So we could have gotten this exact same answer, 8 times 7 times 6, by dividing 8 factorial divided by 5 factorial, and then the 5's divide to give us 1, the 4's divide to give us 1, and so forth and so on. So all these things just give us 1, and we're just left with 8 times 7 times 6. So what we have on the top is the number of teams, and we're going to call that n. N is the number of objects. And then we're going to call R the number of objects to be selected. So to make this into a formula, what we'll do is say that we have n factorial, the number of objects, in this case it was 8 teams, divided by what we're going to say is n minus r factorial. So we take the number of teams minus the number of teams we want to see how they finish, and that's going to give us our answer. And so in this case, if we wanted to find where n is 8 and r is 3. That would be 8 factorial divided by 8 minus 3 factorial, and that gives us 8 times 7 times 6, which is exactly what we wanted. And this is what's called a permutation. So this permutation right here, for example, is P83. So that means we have 8 things to choose from, and we want to choose 3 of them. Again, this is called a permutation. And this is the formula for a permutation. This one right here. And we can also do this in the calculator. So we'll turn our calculator on, and what we'll do is we'll hit 8 to select the number of objects we have, math, over to probability, and down to permutation, or NPR. So we have 8 teams. We want to know how many different ways the top 3 could medal, and that is 336 different ways. Now, a permutation is used in which the order in which the objects are selected matters. So if we go back to our swimming example, we can see that USA, France, and China came in the top 3 places. But if we switched those around, it would have looked different, right? If the United States had come in 2nd place, China came in 1st, and France came in 3rd, for example, that would be the same 3 teams, but it would be a completely different result, right? Because the medals that the teams got would be switched around. So that's what makes this one a permutation. Let's look at what makes a problem a combination. So let's say we're going to order a pizza, and specifically let's say it's going to be pepperoni, ham, and chicken, let's say. So you want to order a pepperoni, ham, and chicken pizza. So there are 8 toppings here, and we want to know how many different ways could we select a 3-topping pizza. Out of the 8 toppings. Now, this is a pretty similar scenario. We have 8 objects. We want to choose 3 of them. But in this case, the order doesn't actually matter. So I could order a pepperoni, ham, and chicken pizza, or I could order a chicken, ham, and pepperoni pizza, or I could order a ham and chicken and pepperoni pizza. And no matter how I say those 3, I'm going to get the same pizza. So this is a problem that's what's called a combination. And a combination is very similar to a permutation, or the order doesn't actually matter. We can do it in any sort of way, and we'll get the same pizza. So it starts off the same way for the formula. We would have 8 factorial divided by 8 minus 3 factorial. But we also have to take care of the fact that we could rearrange these 3 toppings a number of different ways and still get the same pizza. So what we're going to do is kind of similar to what we did before. We got 3 blanks for our 3 different toppings. So if we know we want pepperoni, ham, and chicken, then there are 3 different ways to choose that first topping, 2 for the second and 1 for the third. Or there are 3 factorial different ways to rearrange those toppings and have the same pizza. So what we want to do is we want to divide that out, because any way in which we rearrange chicken, ham, and pepperoni, we still get the same pizza. And so this is the formula for a combination. So this is combination 8, 3. So 8 factorial divided by 8 minus 3 factorial times 3 factorial. And that's going to give us 56. Which we can also do in our calculator. So the way we would do this one in the calculator is very similar to the permutation. We'd hit 8, and then we'll hit the math button, over to combination, or over to probability rather, down to combination in CR, and then 3, and that of course gives us 56. So if we have 8 objects, and we want to choose 3 of them and the order does matter, like our swimming example, there are 336 different ways. If we have 8 objects and we want to choose 3 of them and the order doesn't matter, like our pizza example, there are 56 different ways. So that's the difference between permutations and combinations, and that's how we work them in the calculator.